everyone. Today we are going to talk about one of traditional SPC chart, Short control chart. Short control chart is the simplest monitoring and detection method. It named after Walter Short, who worked as a statistician at Bell Lab. Here we consider a univariate quality characteristic X. X can be like a critical dimension of a manufacturing part, the number of emergency room visit at a hospital, and so on. We assume that X follows normal distribution with mean mu and variance sigma square. This means we model the variability of the process as normal distribution. This model assumes that the observation of X at different samples are independent. That is, we assume that observations are from an identical distribution and independent each other, which is called the IID assumption. As you notice, X is a random variable, and so its values change constantly, but the underlying distribution it follows may or may not be changing. This underlying distribution characterizes or regulates the behavior of X. The change we want to detect is a change in the underlying distribution, not the values of X. Since the distribution is parameterized by its parameters mu and sigma, the change detection is to detect a change in mu and sigma. This is a very important concept. When we talked about variation in the previous lecture, we considered the process in which only common cause variation is present to be in control. Now we can define the in control state by the state when mu equal to mu zero and sigma equal to sigma zero, where mu zero and sigma zero are the target mean and variability, respectively, associated with the process. And similarly, the out of control state can be defined by a state when mu is not equal to mu zero or sigma is not equal to sigma zero. When the process is out of control, we can say that special or assignable causes are present. Therefore, when X follows normal distribution, there are three possible scenarios where a process becomes out of control. This figure illustrates those three scenarios. One is mu is not equal to mu zero. Another one is sigma is not equal to sigma zero. And the other one is mu is not equal to mu zero and sigma is not equal to sigma zero. Now let me introduce the basic procedures of Short control chart. First, periodically and regularly collect samples of n observation, x1 to xn, where n is known as the sample size. And second, from each sample, we calculate one or more quality-related sample statistic. Here, sample statistic means a function of n observations. For example, sample mean is a sample statistic that is associated with mu, while sample range, sample variance, and sample standard deviation are sample statistics that are associated with sigma. We select one for mu and one for sigma. Third, plot the selected sample statistic versus the sample index. Fourth, for each statistic, set up an upper control limit and a lower control limit. Last, for any sample, we conclude mu is not equal to mu zero or sigma is not equal to sigma zero if the sample statistic is not within its control limit. Here is a simple example. Let me go through those 5 procedures with this example. Suppose that we regularly collected 25 samples, each of which consists of 5 observations. From each sample, we calculated sample mean X bar and sample range R. Consequently, we obtained 25 values of X bar and 25 values of R. Next, we plotted those values versus the sample index as shown in the right figure. In these figures, horizontal dashed line represent the upper control limit and the lower control limit. Lastly, we look for any value that is not within the control limit. 16th observation gave a large value in R, which is very close to its upper control limit. But it turned out that it's still within the control limit. Therefore, we conclude our process is in control. Let me wrap up today's lecture. We talked about underlying assumptions of Schwartz control chart, the concept of in control and out of control under the assumptions, and 5 procedures to construct a control chart with a simple example. Next lecture, we will talk about details of Schwartz control chart and 4 important general questions that should be answered in constructing control chart. Thank you.